Uh, Thank you everyone for joining this webinar, and I think this is awesome webinar. I always try to chime in and listen whenever I can. But today, for my topic, I'll be talking on irrigation efficiency in urban and small farm settings. And I know I do have 30 minutes, so I would like to cover like the main crucial points that's important to be water efficient in these small farm settings. And without further ado, let's look at our objectives. So why is irrigation needed? After this is the things that I would like you to know, not like know it by heart, but at least like have an idea on why is irrigation necessary. What are the factors that are important for efficient irrigation in small farms? A little bit on water pressure and optimizing irrigation systems, and like increasing organic matter, using smart controller, checking leaks and distribution efficiency. So things like that. So why is the first thing? Why is irrigation needed? In any small farms, we are mainly concerned on the mass or the products such as fruit and vegetables and things like that. And to produce that, plants need to photosynthesize, and they also need to take water. So as you can see this in equation, 6 CO2 plus 6 H2O gives glucose and oxygen, which is the byproduct, which is the food and the thing that we're interested on. So water is needed for photosynthesis and to make food, for movement of nutrient and sugar inside the plant. It increases the yield. Plant also have the water requirement in itself, so we need to accomplish that. Also the thermal stability and germination of seeds. Now plant do need to take more and more carbon to make more and more product, but then they also need to transpire. So although water requirement for all these photosynthesis and things like that may be less, the transpiration is huge. Like 90% of the water taken up the plant is transpired. So and there's a lot of things behind this, which would be a new lecture or maybe some other time. But plant do need water. So to apply the water, we irrigate, right? So we have different kind of irrigation system in urban and small farm scenario. Mostly I think is overhead irrigation and drip irrigation. Those are two major kind of irrigation system. Hydroponics is emerging and it's really efficient. So I wouldn't talk about the efficiency of hydroponic system here, but the overhead is less efficient than drip. So the first thing to be efficient in irrigation requirement is to consider the pressure. So irrigation parts such as pipes, nozzles, everything you have in an irrigation system is marked up with a pressure requirement. Now, if you go beyond that pressure, you might be in a situation where you will damage your nozzles or emitters, or you might even pop up your joints in the pipes. If you go below that, if you go below the required pressure, then you might not apply enough water, or underwatering, or the pressure wouldn't be high enough so you cover all your spaces. So there should be enough pressure. Now we can put a pressure check valve, a regulator valve in a water source and say like, okay, this looks 35, 40, it's good for my drip irrigation. But it's not that simple. As a small farm producer or in an urban setting, you might have a large production area and the pipes might be running maybe 100 feet or maybe 200 feet, and you are using risers, pop-up emitters, maybe drip irrigation system on those pipes. Now you need to understand that as you move forward or as the pipes are longer, there is reduction in pressure. So it's not only crucial that you measure the pressure at the source, you also need to measure, or at least think about monitoring that in the end zone, or wherever your risers are. Now, say you have a lower pressure 100 feet away from your source. What do? You might use bigger pipes compared to smaller pipes. And also you need to remember that as you move up in elevation, the pressure decreases. So you need to compensate for that. Now, that's a lot of things, I know, but this can be easily done by pulling up a friction loss chart for your desired pipe. Say you are using 40 schedule 40 PVC pipe. You can look up their schedule chart and you can see the flow rate here. So this would be your flow rate. And then this, and per 100 feet of pipe, the pressure loss for 10 gallon per minute flow rate would be, for a half-inch pipe, it would be 35 psi, which is huge. But now if you go with 1 inch, it would only be 2.63 psi. So see how that can make a change to make your irrigation more efficient and not reducing pressure. Same thing with when you are moving up hills, or if you are in a slope area, you will lose 0.433 psi per 1 foot of elevation change. So you need to consider that. So as I already told you, there is a static pressure which you check at the entry point, but there is also dynamic pressure which you check when all the emitters are running. Maybe you have enough pressure when everything is closed, but then what about when everything is running in the system? That might go lower and your nozzles or emitters might not function properly. So you might consider doing a dynamic pressure or operating pressure check, or you can take this at the end of pipes with all the water running, and it will give you the dynamic pressure. It's always a good idea to install a pressure regulator at the main line. Also, sometimes we do tend to have a pressure regulator at a solenoid valve or in zones, if that's what you need to, or if you have a really high pressure in the pipes. Sometimes if you have a small system and you don't go with the hassle of installing a big pressure regulator at the source, and you have an overhead system like this picture here, you can install a pressure regulator in this risers itself, and then these emitters would be functioning properly. So there are a lot of places where you can install the pressure regulator, and then understand that checking pressure and maintaining pressure is crucial for efficient watering. Also, you need to understand the pressure requirement for nozzles. And as I already told you, if we have higher or lower pressure than the nozzles been customized to, then we might not have the desired irrigation efficiency. So, for example, if you look at this RVAN14 nozzle, which is 360 degree, at PSI of 30, the radius would be 13 feet, but at PSI 45, it would be 14 feet. Now, if you go above 45, it would be 50. At 55, it would be 15 feet. And then with all of these, your flow rate changes. So consider this in the sense that the zone that you have customized your head to, or the emitters to, and consider the water that you would be using. So from 1.1 to 1.45, that's almost like 40%, close to 40% more water per minute. So we need to understand that, like, what is the pressure requirement of my nozzles, and is my irrigation system supplying that pressure? Reducing the pressure is easier. Oh, yes, it's easier. But if we already have a low pressure, and bumping that might be a little harder. But there are ways to do it. If the pressure that you have in your farm is lower, you can divide into more smaller zone and do alternate watering. Say you water this zone at 1 o'clock and the other zone at 2 o'clock. That way you would not be running a big zone at the same time. Have emitters and nozzles with a slower flow rate, which I will talk about in later part, and have defined flow rate and nozzle emitter throughout. So you need to have you need to know how much you are sending, how much of water you are applying to the system. So these are the crucial elements of a pressure and nozzles, like how they interact. Now, this might not be a big thing to do with your irrigation efficiency, but I would always like to keep this thing in the presentation when I talk about irrigation is you need to have a reliable backflow preventer so you don't get fuel. So in case of like a fire hazard or a fire truck pulling the water from same hose that you are, or same pipe that you are using for your small pumps, the pressure in the main line may be lower than what you have in your line, and then the water from your production system might go into the main line, which is a concern, mainly if you're using agrochemicals or injectors with pesticides and fertilizers. So always have this backflow preventer in the system. Just a take home. Uh, and now, when we talk about irrigation, efficient irrigation, we also need to talk about nozzle selection. Now, there are a lot of different nozzles made by Rainbird, Toro, Hunter, whatnot, different companies. But they all are different if you look closely on their operating principles. There are fixed arc nozzles that are fixed and apply certain amount of water, doesn't move. There are nozzles that move. There are nozzles that have different terms such as MPR, HEVAN, Precision Pro. So what I wanted to know you in this slide is you need to understand that these terms like HEVA nozzles, when you try to shop for nozzles or buy nozzles, go to their website, look at these, and when you go to Rainbird and you look at their fixed arc nozzles, you would easily find out this thing, HEVAN. So this is high efficiency VAN nozzles, so variable. Um, uh, sorry, I just yes. So this is I just that just skipped my mind. But anyway, this is a high efficiency variable arc nozzle, I guess. And what it does is it's more efficient. It sends a bigger droplet, so there's less wind drift. It increases the distribution uniformity, and they have a lot of physics that's going in when they make these different kind of nozzles. Now there are other nozzles that's like precision nozzles, pro nozzles. So all of these high efficiency nozzles, what they do is they use less water, somewhere from 20 to 30% less water, and they have lower flow rate. Um, so you save water. You basically save water, and you are more efficient. Now there are this other type of nozzle known as MPR, or mixed precipitation rate nozzles. What this means is, say you have a nozzle that you can customize your arc. When you are using it as 360-degree to just apply water everywhere, the output would be 4 gallons per minute. But say there is a condition where you just want to change that arc to 180-degree. Now a conventional nozzle would be pumping out that water, like 4 gallons of water in 180-degree, and same 4 gallons of water in 360-degree. But with mass precipitation rate nozzles, when you do it to 180, then it will only send half of the water that it sends to 360. If you go to 90, it's only sends 1 gallon of water. Now you see the water saving with the customization. So watch out for these nozzles like mixed precipitation rate nozzles, and this will definitely save some water in irrigation. There are also other nozzles such as rotatory nozzles, which now think about this. Say you have a slope land, or maybe you have a clay soil, and you are using a fixed spray nozzles, which is just spraying water and it's just going there, going there, going there. Now, to make it that efficient, you might need to go with time cycle or irrigation cycle of maybe 5 minutes so you don't overflow. But with these nozzles, like with rotatory nozzles, they apply water slowly, and then a zone would get water, and then it would switch up to a different area, and then it would just rotate. So that way, there is higher infiltration time for water, so it goes low, well below the root zone, and it also has less operating pressure, and it needs less. It sends less gallon per minute, and it's suitable for slopes. So you need to understand that there are different kind of nozzles which you go online, you can find them. If you go to a Rainbird, if you for the top class, they say this rotatory nozzle is good, you can use any, but for slopes, it's this rotatory nozzles, but it's not advisable to use these. So there are these resources that you can go and look for and understand these terms to increase the water efficiency. Now, to reduce the inefficiency for overhead irrigation system, you only need to use low volume nozzles and also high efficient nozzles. If the pressure is low, you could also go use booster pumps, but then you would need more water, which booster pumps pull, and that might be a concern. In windy area, you can use low angle nozzles and things like that. So These are all for overhead irrigation. Now for drip irrigation is very efficient in terms of water. So there are a lot. If you are interested to convert your overhead irrigation to a drip irrigation, there are a lot of these drip conversion kits which you can easily buy and hook up to your system, and then your efficiency of your irrigation would change from maybe 60% to 70 or 80 or 90%, depending on what you use. And for drip irrigation, you need to have a filter and a flush outlet. Filter usually 150 to 200 mesh, and flush outlet would be one when you have debris or things like that. You can open that flushing outlet and let the water run, so you take all those debris out from your system. Uh, Pressure compensating emitters and tubing is always advised when we use drip irrigation system, because in the drip irrigation system, the water flows slowly. And if you don't have that pressure compensating emitter, what happens is the zone that is close to your water source would have higher output. And then as you move away, there is this difference in pressure, right? So your zones at the end doesn't have that pressure. So you would be watering at different efficiency and to water enough for your zone at the back end. You might be using no more water. So always consider using pressure compensating emitters in the drip irrigation system. When you are installing a drip irrigation system, check pipe pressure ratings and UV resistant rating. These are something that will increase the longevity of your system. It's good to have an air vacuum or a relief valve in a drip system, where what it does, it releases the air out of the drip system, so the irrigation is more efficient. Now, if you want to look up the pressure loss in drip irrigation system, you can go online. There are numerous calculators which can do that. And also there are a lot of guidelines. Like this is one that I pulled out, like if you have a clay soil, loam soil, if you're using turf versus ground cover versus turf, or other plants that we are growing. There's these guidelines on each irrigation company's website, which you can pull up, or it's here for you to view. And this presentation is being recorded, so you could see this later on at your leisure. Now, one thing to understand is clogging of emitters also make emitters inefficient. So if we have water with high pH, if we do not include filters, or there is a constant fertigation going on with the high evaporation rate like in Utah, then the problem of the emitters clogging both in drip system and overhead system might be a problem. So watch out for that. And what you can do is, usually it can be remediated by injection of a very low concentration acid, or you can search for products in the market which is easily available, and Google different products. I can't make on any recommendation for any specific product, but there are tons out in the market which you can just put in your system, flush it out, and it'll clog, it'll clear the clogging. Also, soil consideration. Now, each urban farm might have different soil. So some have the sandy soil, some have more clay soil, some have in between. What we need to understand is the infiltration rate for the sandy soil is faster, and for clay soil it's slower. Also, clay soil, it spreads out, but sandy soil, it just goes down. So for a clay soil or a clay kind of soil, we need to have low rate irrigation for a long time. And then you can go with a little infrequent irrigation, so you skip some days. But in sandy soil, we need to go more frequent, but a short duration. If we go with a long duration for a sandy soil, we'll just percolate a lot of water below the root zone. If we go if we go high rate with clay soil, we'll run out of water. So also, if the soil is too compact, the water can't infiltrate. So consider aerating the compact soil. Organic matter, this is very important. Yeah, the soil should consist of around 4 to 5% of organic matter. And you can see 1% increase in soil organic matter can hold 16,000 gallon of plant per acre, a gallon of plant available water per acre. So that's really important. And we do a soil test, And if the organic matter is really low, I would advise you to include organic matter. Usually, organic matter such as like compost or peat moss or something like maybe even leaf litters or anything that's made of organic material. We could also use inorganic matter such as perlite, vermiculite, gravel to reduce the compaction, but the water holding like perlite and vermiculite might do a little good, but then you wouldn't reap all the benefit of those microbial interaction and things like that. So I would consider going with organic material. Now, the weather consideration, we need to apply the enough amount of water that's able to supplement the evapotranspiration. That's basic, right? So when we are applying water, we need to consider the evapotranspiration. Evapotranspiration is the amount of water that's lost from the soil and the plant leaves. So that's the water that's gone off soil. So when the plant need water, it's gone. So we need to apply the water to replenish that evapotranspiration factor in the soil. Now, depending on your crop, you might not need to apply 100% of what's gone because some plants, such as native plants, are more efficient. But usually, when we are growing plant from production purposes like vegetables and fruits, uh, we are in that close range from 80 to 90, sometimes maybe even 100%. So look up your weather data. Here is this climate.usu.edu. If you go to the link here, there are a lot of weather station, and if you click the weather station that's close to you, you can pull up something like this evapotranspiration, and you can see daily or monthly or things like that, which will give you a general idea on how it changes so that you can change your watering practices. Also, it changes by location. So if you are living in Logan, this is pulled up from 2016 to 2020. In Cedar City, it might be like monthly evapotranspiration might be at the peak month, might be 8.5 or something, but in Logan, it would only be like 6.5. Now, again, if we get a lot of precipitation, you need to subtract that precipitation and then only apply water. That's that difference. But I mean, you get the point, right? You need to understand the weather factor and the evapotranspiration of the month and then water accordingly. One way to do it easily is through smart controllers. What smart controllers do is pull up the water from that weather station and then change your runtime based on your soil type, based on your plant factor, based on a lot of other things, based on rainfall and things like that. But again, in Utah, it might be raining in like maybe 2 miles from there, and then it might be dry here. So don't leave everything to weather smart controllers, but it's something to consider, and there are a lot of rebates program going on. So I mean, if you want to get one and replace it, you could do it easily. So use the smart controllers. Also, hydrozoning and checking the leak. Now this is very common, and it's I mean you would even think, why am I even talking about this? But still, when we talk a lot about hydrozoning and leak check, there still seems to be a lot of water lost because of these problems. So hydrozoning is if you are growing a crop that require a lot of water in June and planting with a lot of crop that required a lot of water in July. Now you need to apply same high amount of water in June, high amount of water in July. So that's a loss of water, right? Instead, why don't we separate out water by hydrozones? Maybe we have a different zone for water that require the plant that require high amount of water in June, and then have a different zone for plant that require high amount of water in July. So that way, we can apply water when the plant need it most and save water. Also leaks. You need to regularly check for the leaks in the system. Plant consideration. So usually for the plants that's like the vegetables and annuals and those crops, the plant factor would be close to 1 or around 0.9, but it differs during the different time of the year. So this is the reference evapotranspiration that weathers pull up, but our plant might need different watering than the amount of reference evapotranspiration, which is usually crop factor. And there are a lot of crops, and I can't include all those KC for different crop at different stages here in this. So I have the links. These have KC value for a lot of crops. So usually, generally, for a vegetable crops or fruit or something like that, in the initial stage when they are just growing, the water would only be needed like 0.6 to 0.7, or 60 to 70% of evapotranspiration would be needed. But then when they are actively growing and producing, it would be close to 1. Again, the final stage, it would be a little less. So we need to understand that. Now, mulching and shade cloth. So mulching, when we have mulches, like maybe a layer of hay or this something like this as a plastic, what they do is they limit the evaporation. They limit the evaporation from the system, and also they limit the weed production. So weed would be coming up and transpiring, right? Now, if you have these barriers, mulching, then they would reduce that. And then you can easily understand that it will reduce the evaporation and evapotranspiration from weeds. So that would equate to using less water. Also less management. Also, we can use shade cloth. Shade cloth blocks the sunlight, and we do tend to have a high intensity sun in Utah. So in summer, so if we have that shade cloth, we can lower the temperature of our plant growing area, and then as the temperature goes lower, they will transpire less, and that's less irrigation. And it also has a other benefit of reducing photooxidative damage to plants. So all these factors, if we follow these, we might be efficient in conserving water. But then these all starts with a plan. Um, I don't know. Okay. So the plan is start with installing of irrigation system. So you need to create your plan. You need to map area. If you are using emitter head, you need to make sure there is head-to-head coverage. Drip emitters, you don't need to put it directly to the main root zone. Just put it slightly far away so you don't have that disease and other things and salinity built up. Check and modify irrigation controller as required. And consider cyclic irrigation. If you have a constant irrigation spray, maybe 10-minute cycle can be split into 2 5-minute cycles. If you have a sunny landscape versus a shade area where you are growing crops, they will have different irrigation requirements. So we need to consider that. So these are all the basics, from pressure to monitoring weather, to monitoring soil, to selecting nozzles, and considering cyclic irrigation, changing to drip irrigation, and things like that. These are, if we can input these, and if we can do this correctly in a system, we will save a lot of water. Now, there is other additional water saving, such as capture and reuse. You can capture the water that you used, and if it's for the non-food production purposes, you can just use it back. But if you are producing eatable fruit, then there might be pesticide and other factor in the water, so you need to consider that. You can do rainwater harvesting. 200-gallon container can be installed without any registration, or you could have 2,500 gallon of water if you just put your name in the water rights website, and then you can have these things built in, things like that, which will save you a lot of water. And with that, I would like to thank you all, and I hope you enjoyed it. And the floor is now open to questions. But before that, I will just present this here. We are conducting an irrigation optimization study, which we would be coming to you, replacing your traditional controller with a smart controller for free and providing training. So if you're interested, up to that thing, up to the program.